some printing at Cloudera, and yes, thank you. A few months ago, he came and presented Flu to us, and it was very well received, so we were forced to call him back. And this time actually talk about data movement. And interestingly, him and I, as I learned, share a common algorithm. So welcome, Ray.
Okay, so I've been here before, and I don't know how many of you were there last time. Last time I talked about Apache Sqoop. So Sqoop was designed to move data in real time from production systems into Hadoop or HBase or similar systems. So this time I won't talk about real time. Instead, one of the common things which most people want to do is to actually move data from SQL-based systems, databases, data warehouses, into Hadoop. So the system for that is Sqoop. So Sqoop 1 has been in production in many places for a number of years, and it's been extremely successful at what it does. But like most first-gen systems, it has its flaws. And we realized that it is possible to actually go back and make changes in the design, change the way the data is moved, change the way you actually drop plugins in, and essentially that meant rewriting most of the code. So, welcome Sqoop 2. Before I go on, I must say that most of these slides are actually thanks to Yarsted's Ketcho and Kathleen Ding. I pretty much took their slides and changed the name. What is Sqoop? Yes, Sqoop is again an Apache top-level project. The idea is SQL to Hadoop. That's Sqoop. So it's primarily meant to transfer data from relational databases, Teradata, MySQL, Postgres, Netezza, and a lot of other systems into Hadoop. Primarily HDFS, we also support Hive, HBase, Avro format, etc. etc. Sqoop also can move data in the opposite direction, from HDFS into a SQL-based system. Now, the first question is, really, do you need Sqoop? Can I just do like a SQL dump and then copy the files over into Hadoop? Yeah, you could do that. Well, you could do that in most cases and remove most of the systems you have ever written, right? You could just replace everything with shell scripts. But you most often want to do it in an efficient and resource-constrained or controlled way. You want the amount of resources, you want to control the amount of resources it uses, you want to be able to say, okay, this is going to run in n number of hours. And you probably want to restrict the number of connections made to the database because it is possible that that is the database serving production. Now, it also brings up the question of how you map types. So Sqoop supports mapping types from SQL types into Hadoop-friendly or Java-friendly types also. And users can override this by specifying patterns. Another aspect of Sqoop is that it allows you to propagate metadata in several different forms. You can write a metadata into Hive Metastore, which is probably one of the most, one of the systems which most Hadoop users are familiar with. Then we have Avro, which is a structured way of representing your data. So Sqoop allows you to actually transfer metadata from your SQL-based system into Hadoop, which you probably won't be able to do that easily with a shell script. Now, what is the architecture of Sqoop? How was Sqoop 1 designed? Sqoop 1 was designed pretty much like this. Sqoop 1 was a command line client, and Sqoop 1 is a command line client. So you basically run Sqoop on the command line, and then you pass in a bunch of parameters. The number of parameters, okay, I don't think people have actually counted the number of parameters you can pass to Sqoop 1. It is somewhere between 60 and 70 parameters, and the problem with that is you have no idea which two parameters can be combined together. And then you have 60 parameters. Try using them together, right? So in that case, Sqoop was a little difficult to use. Some parameters never worked with the others, some parameters were mandatory, some parameters were not. So such a system was difficult to use in many cases unless you actually had an expert or you spent time and became an expert. So Sqoop 1 was entirely a MapReduce client. So it's not work like this. A Sqoop client would actually submit the job to the Hadoop cluster directly. The Sqoop client also needed access to your SQL cluster, or if you have a single MySQL machine, to that one. So you can actually authenticate with that, log into that, and read the data or whatnot. So Sqoop 1 actually was completely client-based. The problem with this system was, as you can see, the client needs to access everything. And a second problem with this is because it's a command line client, you really cannot save your job and then say, oh, re-execute this job and move more data. You actually just save the command line into like a text file or something and re-execute it, which is not probably the best way to do this. So that is one of the major usability factors which Sqoop had. The second thing is Sqoop was entirely based on the concept of connectors. A connector is simple. It's exactly like MySQL or whatever, right? The idea is read from the database, write to Hadoop, or do it the other way around. The problem was that the way it was designed, was the connectors actually did a lot of work. It was not just taking the data and handing it over to Sqoop and telling Sqoop to dump it in. Instead, it was actually meant for the metadata lookups and the data transfer. And most of these connectors were JDBC based, so most of the systems that support JDBC, you can actually write a connector to this to Sqoop. Now there are non-JDBC connectors which are direct connections, which in some cases are closed source to actually read the data directly from the databases or write it directly to the databases native format. The problem with this was the connectors were actually responsible for most of the functionality, which meant connectors actually did not implement all the functionality that was supposed to be done. It is possible that certain connectors implemented certain features and did not implement a bunch of the others. So, coming to why we actually went to Sqoop 2, pump up the version, change the way Sqoop worked, it was because of a bunch of issues. The first one, the command line arguments, like I said, combinations difficult to use. The second one was security concerns. Because you're actually executing this in the command line, you're passing a bunch of information on the command line, which you probably don't want to do. Then the type mapping wasn't clearly defined, because it is possible that you could override these from a user's perspective and all that. The clients actually needed access to the Hadoop binaries and the Hadoop configuration to actually submit the job. And sometimes in production environments, you don't want to be able to deploy that kind of information on a time machine. And the last one was that the JDBC model was sort of strictly enforced. People not familiar with JDBC may not find it too easy to use Sqoop. And coming to the functionality which we already mentioned, it is the connector's responsibility to actually implement a bunch of the functionality. It was a problem because of the fact that not all connectors implemented everything, which meant that the functionality available from Sqoop was not uniform from connector A to connector B. And this also meant that there was duplicated functionality. If two connectors had to implement the same functionality, they basically had to duplicate code. They had the same functionality implemented either in the same way or different ways in different connectors. And well, Sqoop is equal to Hadoop, so it was pretty much coupled with Hadoop. So welcome Sqoop 2. What we changed in Sqoop 2 was instead of actually having clients do all the work, we brought in a Sqoop server. Sqoop server sits in between, and it has an HTTP REST interface. So the connections are made from the client to Sqoop server, and the client basically configures a bunch of things, and then says, okay, transfer this data from database A to database to Hadoop. In which case, the clients actually never access the database itself. It's only the Sqoop server that actually accesses the database. So the Sqoop server basically needs access to the MapReduce, the Hadoop cluster, and the actual MySQL cluster or Oracle or whatever you're actually trying to connect to. So the clients basically only need to talk to one server, which is your Sqoop server. We had a bunch of goals when we actually started designing it. I wouldn't say I was a part of a bunch of design because I actually wasn't involved with the Sqoop project at the time, but I have been involved with the Sqoop project for some time to know actually that most of these are very valid concerns. So the first thing was the aspect of security and separation of concerns. You basically wanted to say, hey, this guy is an admin, user A is an admin, he can create connections to databases, he knows the passwords to connect to databases and all that. And everyone else is a simple user. He can access these connections, but he can't create new ones. He can submit a job saying, read from this table, but he cannot actually say, okay, connect to this database, because he doesn't have access, he doesn't have the passwords. So such a system allows administrator and user and being able to say that certain users have certain privileges which other users do not. Another aspect of this was when we started working on Sqoop 2, we realized that we had to actually change the way connectors work. Connectors should do exactly what they are meant to do. Read from the system and write to a system. So the idea is that the connectors would simply read from the database, hand the data over into Sqoop, or the other way around. It would basically read the data from Sqoop and write it to the database. So the idea of being able to make connectors simple is appealing for most users and most vendors, database vendors, who want to write connectors because they don't really need to do a whole lot of work. They don't need to understand Hadoop. They don't need to understand how input formats work. They don't need to understand how to write data into Hadoop. More importantly, if the connectors are minimal and most of the functionality is moved into Sqoop, it meant that if a connector provided the basic functionality, Sqoop would be able to provide the rest of the functionality, in which case all connectors would be able to give you the same level of features, rather than saying that, okay, I won't write to HBase. So because of that, you would actually just make the connectors completely domain specific. In Sqoop 2, instead of actually having everything on the command line, we separated it into two parts, connections and jobs. So a connector basically defines the way connections are made. Connector would say, okay, for a connection to a database, I need certain set of certain data, like the username, password, the URL to connect to, and stuff like that. So all that would go into a connection. The idea is that this connection would be persistent in Sqoop itself. Sqoop would have a repository where all this connection information is saved, and giving role-based access to users would mean that administrators would be the only ones who would actually create and change these connections. The second part of it would be the job. If you think about it, that's exactly how you would write programs in Java, right? You actually create the connection and then you would submit the SQL query as a job. So the job is what people usually want to do. People want to just read data from a database. They need not actually know the credentials to log into the database if someone else has already done that for them. So a normal user would be able to run a job and create jobs and run jobs without actually having the credentials to directly create a connection to a database. Now with each job, you could configure how the job is done, how the job writes the data out, where it writes it out, should it compress the data, and things like that. So the idea is that the job would be, you create the job once, and then you can resubmit the job as many times as you want. Instead of actually having all this stuff in the command line, you created the job once, it saved it to a repository inside Sqoop, and then the next time you actually want to, move the data from the same table to some location on HDFS, you just rerun the job. You don't actually have to sit and type 60 parameter command. So how does Sqoop work? Sqoop 2 in this case. So connectors basically register and upgrade metadata when you actually do upgrades. So they upgrade, register and upgrade metadata and say, okay, this is the metadata for a certain job and certain connection and certain job. Now, when you create a connection, that is the metadata which you fill in. When you create a job, again, the connection-specific metadata is filled in. Now, with this metadata, you can actually create jobs and connections because you know what the parameters are to connect to a specific database which is provided by the connector. So, given that the metadata is already available, you could have a web page, or right now Sqoop 2 has a command line client which says, okay, give me this metadata and I'll create a connection for you. This information is stored in a database within Sqoop itself. So Sqoop actually maintains currently a Derby repository. And because of this information is persistent from execution to execution. It's pretty much like an available service where all the data is already stored inside. All you need to do is to give the inputs or actually just execute jobs based on the inputs already available. The operator usually just runs the jobs. The operator basically selects, hey, run job 1 and run the job and read from the database and write the data Hadoop. Now, the admins would basically set the policy for the connection use. A little caveat here, some of these features have not been implemented. Star conditions apply, they will come in the future. So, the role-based users have not been implemented completely yet, which is why Sqoop 2 is still at Sqoop 199.2. We have not reached Sqoop 2 yet. Sqoop 2 would support security. Considering the fact that most systems in Hadoop use Kerberos-based security, it is actually possible for Sqoop to write to Kerberized systems given the correct credentials. Now, since another way of separating of security is actually security to access Sqoop itself and understand a user's role, understand if the user is an administrator or a normal user. Sqoop 2 security coming soon. The current status of Sqoop 2. Sqoop 2 is currently at Sqoop 199.2. We haven't reached Sqoop 2 yet, but we are really close. We'll probably reach 199.3 and then go to Sqoop 2, depending on how the community decides to go ahead with it. Documentation and downloadable bits are available at sqoop.apache.org. So we already have a considerable number of committers, and we have a lot of contributors who actually contribute lots of code to be able to move data from databases into Hadoop. And we actually want you to actually contribute code to us. Because this is probably one of the biggest uses of Hadoop. Make sure that you guys contribute. Thank you. Last time Sumit said I ran over time, so this time I decided I'd run under.
Well, actually, when I checked these slides, I saw the number 14. I was happy last time you had 55.
Did you think it was 41?
But the Flume presentation was very well received. It was an excellent presentation. Actually, if you guys haven't seen it, I would encourage you to watch the recording. If you're interested in these tools, so Flume support for acquisition, this is support for movement. Questions for Hari?
So,
so one quick question. So, introducing Sqoop server in between, does it not increase the network hop? So now we go from IPFS to Sqoop server and then to the client?
So Sqoop server itself doesn't actually move the data around. Sqoop basically submits a MapReduce job. The idea of Sqoop server is meant to reduce the dependence on the client. Instead of the client actually submitting the MapReduce job, the job is still submitted to the Hadoop cluster. It does not go through Sqoop. The Hadoop MapReduce framework reads the data directly from the database. So it's not like the Sqoop 2 server would be, a single point of failure or a bottleneck. Sqoop 2 server is just meant to hold the metadata and the job information itself and submit the jobs again and again if needed.
Awesome. Okay, thanks.
More questions? Or let me go?
So you said it's not a single point failure, but what if it is a failure of the... So what, in other words, let's say if there is no Sqoop server, can client directly come to the cluster?
No, currently not, because this metadata, metadata specific to the connections and the jobs are actually stored in the Sqoop server. So if the Sqoop server goes offline or Sqoop server is unavailable for whatever reason, then yes, you may not be able to submit the job because it actually goes to the Sqoop server. But it's a community project. Somebody's going to come up with an idea that hey, let's replicate the Sqoop server and have two copies. So the first guy dies, let's go to the second guy. We did that at the main node, it's eventually going to happen in Sqoop server as well. So before I leave, HBase folks have asked me to say that HBaseCon is coming up, and it's the community event for HBase. So it's in San Francisco on June 13th. Make sure you're there. That's it. Thank you.
I'm going to name him. Is that it? Yeah.